looked at NET College, a YouTube channel for high school mathematics education. Mathematics 3C, Swedish high school education system. Miscellaneous problems on derivatives. Hi, this is Babak. In this video I am going to solve the following problem for you. Let me read the question for you first. Let f be a function that is differentiable on R, the set of real numbers, such that for every non-zero real number x, 8 times f of x plus 6 times f of 1 over x equals to x plus 5. Let g be a function defined by this rule. G of x is equal to x squared times f of x. Determine g prime of minus 1. I recommend you to pause the video at this point and try to solve the problem yourself first. If you do it correctly, the final answer that you get is g prime of minus 1 equals to minus 1 over 14. Okay, now let us solve the problem. This needs a little bit of experience how to deal with these problems. My starting point is this given equation. I know that 8 times f of x plus 6 times f of 1 over x is equal to x plus 5. And according to the problem, this equation holds for all possible values for x. Yes? So let me tell you that let x be a non-zero real number. Okay? When x is non-zero, then 1 over x is also a non-zero real number. Yes, that is clear. Okay, but let me read this sentence once more. This equation is true for all possible non-zero values that you choose for x. So if my x is a non-zero real number, I know that this will hold. On the other hand, if x is non-zero, then 1 over x is also a non-zero number. So this means that this equation also holds for 1 over x in place of x. So what does it mean? It means that if I replace this x with 1 over x, this equation holds again. So this becomes 8 f of 1 over x plus 6 1 over x, which becomes x. So this becomes 6 of f of x is equal to, instead of x, I put 1 over x is equal to 5. So it is important for me that you understand what is going on. This equation, so I'm saying that let x be a non-zero real number. According to the assumption itself, I know that this equation holds. And now then I'm saying that because x is a non-zero real number, 1 over x is also a non-zero real number. So this means that this equation also is satisfied when I have 1 over x instead of x. So then this gives rise to the second equation. But if you see, I have two equations. This is one equation and this is another equation, and in these two equations f of x and f of 1 over x are unknown to me. But I have two unknowns, one of them f of x, the other one f of 1 over x, and I have two equations. So in principle I should be able to solve the system of equations and find my unknowns. But I am looking just for one unknown. I want to find f of x. So I need to get rid of this extra unknown. But the coefficient here is 6, the coefficient here is 8. I have to get rid of these coefficients, and then you know the strategy of getting rid of this is just to multiply these equations by appropriate numbers so that when I add them, these extra unknown is gone. This extra unknown is gone. So for example, here I can multiply it by minus 6. I will multiply it by 8, and I will multiply the second equation by minus 6. Then what I get is 64 f of x plus a 48 f of 1 over x. On the right hand side I will have 8x plus 40. In the next line it becomes minus 48 f of 1 over x, then minus 36 f of x, it becomes minus 6 over x minus 30. Yes, but it is now seen that I can immediately add these two. So if I add these equations side by side, what I get is, you see, this one and that one are totally gone. Then this one is 64 f of x, this one is negative 36 f of x. If I simplify this, what will happen? It becomes 28, yes? So it becomes 28 f of x. But what happens for the right hand side? If I add 40 to negative 30, it becomes positive 10. And then there are two terms left. One of them is positive 8x, the other one is negative 6 over x. But then I am looking for f of x, so let me write here. This tells me that f of x I divide by 28, so I divide both sides by 28, and then I will get f of x is equal to 10 over 28 plus 8x over 28 minus 6 over 28x. But I can also simplify my function. So here 10 and 28 are simplified by 2. It becomes 5 over 14. So I would write 5 over 14. The next one I can simplify by 4. It becomes 2. This becomes 7. So 2x 7. So it becomes plus 2x over 7. And then I have 6 over 28. I can simplify by 2, 3, and 14. So it's minus 3 over 14x. Yes, so this is the function that I was looking for. Yes. Now my goal is to calculate the derivative of g at point minus 1. So you know that if you want to calculate the derivative of a function at a given number, the first thing that you need to do is to differentiate the function. When the differentiation is finished, you replace the x in the derivative with this number minus 1. But before that, I have to find my g of x. G of x is x times f of x. I already found f of x, so I just multiply this by x squared. Then I can find what is g of x. So g of x is simply x squared multiplied by this. So this term should be multiplied by x squared. It will give me 5 over 14 x squared. The next one should be multiplied by x squared, so it becomes 2 over 7 x cubed. The next one should also be multiplied by x squared, but you see this one of these x's and one of these x's are gone, so minus 3 over 14 times x is left. So it becomes minus 3 over 14 times x. And then this would be my function. But then it is a very simple function that you can differentiate. This is just a polynomial function, so I would say therefore g prime of x is equal to, I have 5 over 14 as a multiplicative constant. The derivative of x squared is simply 2x. Then I will have 2 over 7. The derivative of x cubed is 3x squared. And then finally I have 3 over 14. The derivative of x is 1. And if I simplify this, so g prime of x would be 5 over 7 times x plus 6 over 7 x squared minus 3 over 14. So that is my derivative. And now I am supposed to, according to the problem, I am supposed to calculate the derivative at point -1. So finally I replace x with -1 and I will get my answer. So g prime of -1 is equal to minus 5 over 7 plus 6 over 7 and then minus 3 over 14. Yes? So what I have done, I have replaced x with -1. The first one becomes minus 5 over 7. The second one becomes positive 1 times 6 over 7. And the last one is actually this one. So then I will take the common denominator. The common denominator here is actually 14. So the first one is 2 times, and then it becomes minus 10. The second one is 2 times, it becomes positive 12. The next one would be just the same, minus 3. And if you calculate this, it becomes minus 13 plus 12 is minus 1 divided by 14. So that is actually the solution to this problem. So g prime of -1 is equal to minus 1 over 14. Yes? Okay. The link to the PDF file containing this solution is below the video in the descriptions. I hope that this video was useful for you. Until the next video, be safe and goodbye.